Hi, everyone. Welcome. And thank you so much for joining us for this final session of DX Week 2022. Today's session touches on topics related to the future of mobility. And it's this very important topic of mobility, the movement of people and goods from one point to another, that provides access to jobs, education, healthcare, and trade across the globe. Cutting-edge innovations in areas such as autonomous vehicles, electrification, wireless connectivity, drones, and shared mobility are creating opportunities to transform mobility by enabling innovative business models in addition to safer and more efficient mobility services for new and changing customer demographics. In this session, experts from around the world will provide their take on what the future of mobility may look like in the years to come. My name is Andrew Maywa, and I'm an investment director at TDK Ventures, focusing on investments in mobility and robotics. I have the pleasure of moderating our session today. As with all of the other DX Week sessions, we have designed our panel to include thought leaders representing academia, industry, entrepreneurship, and the investment community. We are passionate about having diversity in each panel. We believe that this will allow for a very meaningful discussion. And speaking of our panel, I am excited to introduce our amazing panelists and get to hear what they have to say. First, we have Sarah Jones. Sarah currently serves as Senior Vice President at New Vista Capital, an investment firm focused on emerging technologies in aerospace and defense. Prior to New Vista, she drove innovation investments, partnerships, and new venture initiatives in the mobility and emerging technologies at Boeing, including serving as Innovation Director, Digital and Emerging Aviation at Boeing Horizon X. Next, we have Professor Florian Holzapfel. Florian is currently a professor with the Department of Aerospace and Geodesy at the Technical University of Munich, where he is also the director of the Institute of Flight Systems Dynamics. Next, we have Ein McKendrick. Ein is the founder and CEO of Faction, which is developing driverless three-wheel electric vehicle fleets. Prior to founding Faction, Ein was the VP of Engineering at Starsky Robotics, which became the first company to operate completely driverless semi-trucks on public roads in North America. Next, we have Maha Ashur. Maha is the founder and CEO at MetaWave, which is developing advanced digital imaging radar solutions. She was recently recognized in the Forbes 50 Vision list for founding MetaWave. Maha holds a doctorate degree in physics from MIT, has authored over 35 publications, and holds more than 75 granted patents and over 150 pending patent applications. Next, we are joined by Moshe Cohen. Moshe is co-founder and CEO of Syconia Flights, which specializes in developing decentralized collision avoidance systems for aerial platforms. Moshe holds a master's degree in financial management for the Naval Postgraduate University in Monterey and a master's degree in political science from Haifa University in Israel. And finally, we have Lin Pham. Lin is the CEO of Vin Energy Solutions, the battery arm of Vin Group, which is the largest private conglomerate in Vietnam, and was featured on Forbes Asia Fab 50 companies list. Lin also serves as Deputy CEO of VinFast, the mobility arm of Vin Group. Thank you all so much for joining us today. The agenda and format today are the same as all the other DX Week panels. We've already started with the opening remarks, which I'm giving now. Then that will be followed by about 80 minutes of discussion based on the answers to two key questions, which are, what is the most impactful innovation that can be realized in the next 5 years for mobility? And what is the most challenging innovation that will disrupt the market in 10 years for mobility? And we will finish our session with 30 minutes of audience Q&A. The answers from our panelists will fuel the initial discussion, and then we will then shift gears and have an opportunity for you, the audience, to get involved. Audience members will be given the opportunity to vote on the answers provided by our panelists to the two key questions. Please note that for members of the audience, we highly recommend that you either have a smartphone ready or have an extra tab open in your browser so that you can submit your responses to the polls using the digital polling tool that we will use to gather feedback. All right, let's get started. To kick us off for this session, for our first question, panelists, please see the link in the private chat at the right-hand side of your screen and click through to submit your answers to what you think is the most meaningful innovation to be realized in the next 5 years for mobility. We will then use these answers to begin our discussion. Okay, we see some answers coming in. Decarbonization, very good. And self-driving, that's a topic that I'm certain we can get a lot of discussion from. Right-sized vehicles. Very interesting. And delivery drones and air taxis. I think there's going to be a really good discussion coming from that one as well. And smart electrification. Yes, indeed. I think that's going to be a very exciting one. All right. If you haven't entered your answers, please do so using the clicking on the link in the private chat. Okay, I think that should be everyone. And it looks like we have a really good set of answers here for, I think, a very impactful discussion. And so thank you so much for the thoughtful answers. Let's get started. So I'd like to get started on the topic of self-driving. Ayn, would you please comment on your thoughts about self-driving?
Happy to chime in. And then, Andrew, thank you for hosting this morning as well. So at Faction, we're a little bit contrarian with some of the approaches we take with self-driving. I always like to differentiate between driverless and autonomous. Driverless vehicles are what everyone's looking for when you think of a commercial application. How do you deliver goods to somebody? How do I bring you a vehicle that you might be able to drive yourself? A lot of our industry has been focusing on full autonomy, which leads you to a lot of AI research, and it really can't tell you when they're going to be fully done. And so companies like Faction, for example, we're trying to hybridize these approaches where we do autonomy coupled with teleoperation, where a human can assist these vehicles on occasion. And this is how we get fleets on the road in the next couple years, as opposed to waiting for the next AI breakthrough. But self-driving is pivotal to a number of aspects of mobility, where it's everything to alleviate logistics problems. How do you enable shared vehicles? It even forces us to develop some of the advanced technologies like digital vehicle architectures that we need for the future of these vehicles. So I'm personally very bullish on self-driving technologies. I've been working on them for a number of years now. But it's about right-sizing the technology to the applications. What are the problems we're really trying to solve? And we need to get self-driving out of being a research project and more into a product. And how do you actually move forward with that? That's really the challenges that we're trying to tackle at companies like Faction and some of the others as well.
Yeah, I think Ayn.
Maha, you were saying?
Yeah. Okay. Yes, I want just to add to Ayn because I'm the one who puts self-driving. I like to bring the topic of Tesla. Having been driving Teslas for 6 years, I kind of was disappointed with the self-driving autopilot, whatever you want to call it, because the driver needs always to hold the steering wheel and the driver is always liable. What is amazing is that Daimler, for their EV cars, their autopilot, they take on the liability. So at the end is who takes on the liability. If it's the driver, I'm not going to call it self-driving. So when I talk about self-driving, is basically the fully autonomous where the liability falls onto the service provider or the automotive, OEM. And as soon as you talk about liability, you talk about the value chain. Who is going to be paying for that? Are these the component providers, the tier ones, the OEMs? And so there will be a lot of consolidation across the value chain to deliver self-driving, but it's going to happen in the next 5 years.
And one other point I'll just add on there is, I think, and this is one of my positions on this, that there's driverless and then there's autonomous. Driverless is what everybody's asking for. So whether it's logistics or bring me a vehicle that I can drive myself, autonomous implies that you have it completely autonomous. It's making AI decisions, careening through downtown San Francisco, differentiating between children and pigeons and all that kind of stuff. That's a research project, and it's going to be going on for a long time. But if you can deliver a driverless experience with a combination of the technologies we have today, such as robotic driving, safety systems, ADAS, et cetera, you can bring a driverless experience to market. And even with vehicles that do teleoperation, if it takes an extra minute or two to get that driverless vehicle to the end customer, they don't know. The magic is the driverless system has just arrived. And as autonomy gets better, the workload for things like teleoperators or the safety systems goes down. And so autonomy research especially will continue to evolve over the next couple decades, but it's not going to gate us from bringing driverless solutions to market over the next 2 to 5 years in volume.
Hi, Lynn. You please comment on the challenges to scalability.
Yeah, so I think I like how you differentiate between driverless and autonomy. But I think whatever it is, I'm curious to see your view in terms of scalability, because I think the way I see it, there are challenges with data sets. It's expensive. You need time to collect it, to train it, to validate it, and it has to be exhaustive enough to ensure safety as well. Also the redundancy, the safety system, how you deal with, complicated and sometimes, a set of sensors that could be expensive and keeps evolving in terms of technology. Also the EE architecture, and also validation effort as well. So thank you.
So actually, Lynn, you mentioned some of my favorite topics, so I'll try to be concise, but I'll also give a little of a reference from some past experience. So I'll start with some of the things that we're doing a couple of years ago, and I'm influenced a little bit by my time I spent at Starsky Robotics, where I was VP of Engineering, and we became the first to run completely driverless semi-trucks on public roads in the US. And the way we did it was really with a combination of cameras, radars, and other sensors to enable us to fit the technology to the mission. And the mission in that case was long-haul trucking. But what we discovered is that you can build a very robust, self-driving system to do highway operations, especially long-haul trucking, and then you combined it with a human operator to handle really the first last mile operations on ramps, off ramps, especially a toll booth, for example, scenario. And what we found, at least with trucking, is the human operators had to assist these vehicles about 1% of the time. And if you just do the math on this, a human teleoperator makes about $60,000 a year. They work in an operations center. If they only had to help the trucks about 1% of the time, that means if you had all of the advanced AI and technology and everything and it worked to be able to do on-ramps, off-ramps, toll booths, local roads, et cetera, the value was actually only $600 per truck per year. So spending $1 billion on technology and AI research to help the truck pick which lane in the toll booth is a complete waste of your funds. So what we did is we said, let's basically make a system that was very deterministic so that it could have a handful of behaviors that we could prove that were working well with regulators. This bridges into your point about safety, where there actually aren't, we have new standards coming out now about safety testing these vehicles, but what we did at the time is we borrowed things from the US Department of Defense, how they use modeling for things like cruise missiles, and before they send an unmanned aerial vehicle downrange at some place like White Sands Missile Range, there was a whole statistical model and there was a safety model for doing this that aviation has been using for years. And so we adapted some of these techniques to the vehicles so we could have a statistical assessment saying that when this vehicle is going down the highway, it has like a 1 in 3 million chance of having an anomaly or a failure, and then another 1 in 5 million chance of the safety system not catching this and safely pulling the vehicle to the side of the road and halting it. And these are the kind of approaches you have to take before you can field them and scale them. And then the last part of your question, I would say, is one of the fundamental technologies that if you start thinking chassis up on the vehicle, you have to start thinking digital architecture on these vehicles. Because they have to have everything instrumented on board, everything from sensors on steering and braking. And this is where I think a lot of the companies that are just focusing on bolting technology on a legacy vehicle are not going to scale anytime soon. You have to think chassis up. And companies like Faction, for example, we work directly with our OEM partners to integrate technology directly into the chassis to set you up for a digital vehicle architecture. And despite some of the shortcomings of Tesla's autopilot, I will concede that Tesla is probably one of the few companies in the industry that actually has a digital vehicle architecture on their vehicles. When they wanted to add, emergency braking to autopilot, they did a software update over the air to the parking brake system. Most OEMs can't do something like that, and so this is also another core technology as we think about the future.
Yeah, I just want to add one more thing. Just driving this morning along the road, it's caused raining and foggy and all of these things. My Tesla flashed red. So the digital actually is not enough. And I'm pretty sure you know what I'm talking about. When you have a truck and all your sensors are on the engine portion, and you have these long metallic trailers, how can the truck see behind to make sure that they are in the lane when they change lane for the cut-ins and cut-outs coming into the freeway and leaving the freeway? So sensors are becoming extremely important. So hardware, we're talking about analog, right? And in particular, of course, the radar, because unlike the camera and LiDAR, it's the only it's the only sensor that can operate in all weathers and also detect objects at much longer range and also avoid the multipath or the interference from the trailer. So, but here's the problem, Ain, is that sensors at the edge are becoming more and more demanding in doing a more, computational power. And at the end, you're cutting your profit margin for these tier one sensor providers. Now you're talking about a more distributed sensor system with a centralized sensor. I go back to my liability question. So who takes on the liability is now the sensors are divided between the edge and the centralized. So there is still a lot of work. And I don't like to use the word R&D or academia because I don't think we are that far. We're very close. We need to be very honest with ourselves and with our customers.
100% agree. And I'll just add, I love radar versus LiDAR for a lot of these applications.
Thank you.
I want to pull on a thread that Ayn brought up on the safety piece. And I come from more of the aviation perspective, but when it's fascinating to watch what's playing out with ground vehicles in terms of autonomy. And I think you mentioned one incident in 3 million. Well, the standard that we have to achieve in commercial aviation is one incident in 1 billion, right? And so I'm very curious as to how, those that are working on ground autonomy are thinking about the level of safety to hold themselves to in the absence of a regulatory framework that tells you what to do. Because at some point, if there's enough incidents, there will be a regulatory framework imposed upon you. So how do you think about that dance of what's the safety level that we need to get to, and also as part of Maha's conversation about the liability, right? Who's going to take on the liability? Because as an OEM, there's a balance between the upfront NRE or development costs, right, to achieve that level of safety. But then, if you achieve a higher level of safety and you have the liability, you have a back end benefit. So what is that balance? I'd be very curious to hear both of you as to what you're seeing on the ground side, because I usually focus on the aviation side, and it's pretty clear for the most part, what we have to achieve.
And so I can clarify my comment quickly. So the model we were using on the trucks, for example, it was a 1 in 3 million chance of having an anomaly that would actually escalate to where the safety system would say, okay, I'm going to decide to halt the vehicle. And then it was about a 1 in 5 million chance that system wouldn't do its thing. So you get this compounding level of statistical safety. And I'll just add that the standard we were actually looking at was called Range Commander Council 323, which White Sands Missile Range developed for how they were using the unmanned aerial vehicles and such. And we like that because aviation actually developed these models and statistical models for how you do this risk assessment. And you roll back the clock a couple of years, and while the industry like automotive would throw around standards like ISO 26262, they didn't always have the statistical models in there for quantifying how safe is it. So I completely agree with you 100% that the aviation level of care is typically much higher than what we've been doing on ground-based vehicles. But at the same time, we can learn a lot from aviation for how you model the risk possibilities for the vehicles, because that's actually what the regulators want to see. And for a lot of us that have actually deployed vehicles on public highways, especially when they had nobody on board these vehicles, going into we did this in Florida, for example, at Starsky. We went into Florida DOT, Florida Highway Patrol. You walk them through all the models, and you make them feel very comfortable so that they know that we're taking due care before we operate these systems. There will be regulatory, I think, at scale over time. It's just that the industry is still very new right now, and everyone's playing catch up. So I think it's on a lot of us who are developing the systems to try to take that care to adopt the best possible standards. And I will concede that aviation was a leader in this because they've been doing it for a lot longer than we have in driverless vehicles.
Yeah, I would like to add one more thing to Sarah's comments. Aerial mobility is it's an emerging sector, the way how I see it, the way how I understanding. So on the sensor side, there is still a lot of work to be done, and Metawave has been pulled into aerial because we are so far the leader on the ground for long-range, all-weather imaging capability with our unique solutions and our IP. So as we were pulled into aerial, we realized that there is a deficiency there in two fronts. Number one is for these vertical takeoff and landing, where now governments are prohibiting the use of cameras. So how can you take off and land if you cannot turn on your camera? So radar is becoming a must in all terrains and also in all operating conditions. Yes, the camera developer has some sort of liabilities, the component provider, but at the end, it's who's providing the service or who's operating the vehicle takes on the full liability. Number two, the way that I see it too, and that came out to me as a surprise, in all airports, you do not have airplane takeoff and land at the same time. And it's because of the lack of sensor on the airplane and on the infrastructure of the airport. This is something that can be retrofitted very easily, by the way, because the technology is existing there. So you have a combination of the vehicle itself and also whatever terrain that is accommodating those takeoff and landing, especially for urban air mobility.
Yeah, I look at the aerial autonomous vehicles a little bit differently. I feel that my perspective is that the vehicles themselves are quite mature. I attended the first summit or the first conference with regard to integration of drones into the airspace. It was back in 2014 in NASA in the Silicon Valley, where you could hear two languages. One was the language of the technology companies that said technology, 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 and the other was regulators that said safety, safety, safety. And the technology, they said, well, we are about to finish and about to finalize, and we can assure that the vehicles, the UAVs, the drones would run safely. They would do everything you need. And they are used with systems like computers that if it doesn't run well, then you switch it off and on. However, the regulator wouldn't hear of it and wouldn't agree to it. He wants the aerial systems to adhere to all the safety standards. And that is, I believe this is the reason that up until today, the skies are not full of drones. However, we are getting there because the technology companies have learned what the regulator mean and what the regulator want. And the regulator, on the other hand, all over the world, in the US, in Europe and Asia, wherever, the regulators have understood that this is a little bit different industry, and you can't judge a little drone the same way you judge or the same way you inspect a huge Boeing 787 or whatever it is. So I guess these elements are getting close to each other, and it's about to begin. The only thing that is remain to be solved is the conflict between between aircrafts, between drones, between drones and helicopters, because nobody wants two drones to collide on board a busy street and fall on people that are just walking there, and nobody wants to take the risk of a drone falling on air taxi. Air taxis are being developed. Billions have been invested so far in the vehicles, in their sensors, in their landing and takeoff, the engines, control, everything. However, the regulations that would on which they would be operated is yet to be constructed, and how they would live together with the little drones, with delivering drones. So imagine a city where air taxis are landing everywhere, taking people from here and there, and there should be many of them. And between them, the little drones with delivering packages, how they would coordinate conflicts among themselves. And this is something that the industry and regulators have not been solved yet. Will they use a V2V network that would all will be connected, or will there be sensors that can do the job? So this is where the industry and the regulators and is standing all right now, trying to figure how they will all live together, how they can be, how the industry, how the drones, how the air taxis can develop to their full capacity.
I want to continue where Sarah was asking to Ain, because I'm a big fan of the statistical models. And one frustrating thing is that basically still in aviation, when you're about to prove functions, the verification path wants to see a very deterministic verification. And now more and more of those functions become non-deterministic because the state spaces are exploding and there is more interaction with the environment. And this is, I think, something where aerospace will be able also to learn from automotive. But I try, and this is my question to you, Ain, I try to capture what are your suggestions on how to come to an agreement with the regulators, as Moshe correctly put it, so that they accept those statistical proofs for endorsing the safe operation of functions, which then MAHA will finally allow the liability to move from the operator to the vehicle.
Yeah, so it's a good question, and I'll, in full disclosure, I've also been a pilot for over 20 years, and so if I wasn't working on ground-based vehicles, I would probably be working on the aviation problem as well. The aviation world has some distinct advantages in which the operating environments are much more structured than what we deal with on the roads, and every aircraft follows a very deterministic transition from ground control, taxi, takeoff with the tower, transition to en route air traffic control, and then you repeat on the way back down. And so it's a very structured way in which you operate the vehicles, and it allows you to actually add those levels of safety and those procedures. So I agree with you 100%, Florian, that it goes both ways. There's things we apply from aviation when we do the vehicles, even like basic things like how do you pre-flight check a driverless vehicle before you actually take it and deploy it and send it out on the roads. No pilot ever gets to the edge of the runway, puts the hand on the throttle and says, "I hope this works." I mean, they've literally tested everything and done a run-up check and everything before the aircraft is deployed, or takes off. So what we do is, the same way in which you want to have a statistical failure model for everything, you need to do a FMEA analysis on every part of your system. So it's the components, it's the sensors, it's the the drive-by-wire systems, it's the network on the vehicle, it's the software that runs on it. You have to have a statistical model for everything that you can put together and bring that to a regulator and say, here's the failure probabilities for every part of the system. Here's our assessment for how well it works. And then we have to be really good at detecting that we are working as intended. So if there's an anomaly in the system, that's where you start a safety escalation within the computer systems, where you start to then halt the vehicle or bring it over to the side of the road. And you have to demonstrate how you can do that and to fit your safety model. And so 100% agree with the comments that it's the operator's responsibility right now. So a company like Faction that's deploying these vehicles, we have to take full responsibility. And to be perfectly honest, I don't know when we're going to be at a point where we would transfer this liability to the vehicle or to the other individual systems. As the companies that are deploying the vehicles, we have to take the overall responsibility. And this is it's a hard one for the existing industry to digest, because if you look at traditional automotive, they make a vehicle with a collection of tier 1 suppliers. And they're victims of being a mature industry, but it's also served them very well that if you're building millions of vehicles every year, distributing that liability for various subsystems to your tier 1s, getting your tier 1s to contribute to the vehicle allows you to scale, and you don't have these teams internally doing all the systems architecture. The problem is you have people like us showing up with new advanced systems, sensors, computers, everything else, and we need to break open the systems architecture and network everything together, put in the safety features, etc. The existing industry is not ready for this. They're not even capable of doing it. So we have to then think about how do we bring digital technologies to the industry, get them comfortable with it, and also work with them to do new systems architectures. And this is why I like to joke that every time you see another driverless vehicle running around on top of a Ford or a Kia or another legacy automobile with a bunch of rails on the roof and everything bolted on, that will never scale. you have to start working with chassis up. And so any of the next generation EV companies are the ones, EV and other companies that are building vehicles from the ground up. If they don't start thinking digital technology now, networking the components, how do they put all the safety features in, they're not going to survive over the next 10 years. They're going to get displaced by the other companies that are moving quicker. And we've seen this happen in places like mobile technology in the past. If everybody remembers when the iPhone launched, the rest of the industry panicked. They didn't know how to respond to a new advanced, handset. And it wasn't until Android showed up with a hardware reference and software to enable others to enter the market, but the incumbents didn't move fast enough. Motorola, Nokia, Sony Ericsson, they got killed by the newcomers. I would argue that in the vehicle space, Tesla's our Apple. They showed up with a digital vehicle, EV, battery train. A lot of the industry only saw the batteries in the EV. They completely missed digital vehicle. They completely missed network sensors, software operated vehicle. And that's really going to be the future for this, because once we get there, a lot of the things we're talking about, how do you instrument it? How do you track the safety of what's going on? How do we actually know the health of those vehicles? These are things that the next generation of vehicles we're just going to take for granted. But legacy vehicle platforms, they can't even do some of the things that we consider basics from a self-driving perspective.
Very good points. I'd actually like to loop in Lynn. Lynn, can you comment on some of the points that I made in terms of developing the digital vehicle chassis up? What are your thoughts on that?
Well, I do agree with him. I think chassis up is something that has to be the case, right? And I think it's sort of the fundamental. So at VinFast, we are doing the same thing. And I think that is crucial for any EV in order to take that approach and be, making a brand name, a quality product, and also an efficient product into the market. I think digital is definitely very important. Now, at VinFast, we are working on a smart electric vehicle. So I think digital is not just for us, mostly for the whole architecture of the batteries of the electric vehicles itself, but also we do we spend a lot of time looking into autonomy, and then we used to debate a lot internally among our teams, different teams, engineers, and also a product strategy team in which direction we should take, basically. Because we're looking into North America, we're looking into Europe, and we're trying to see what is the angle for us, really. And we, at the end of the day, even though we are very crazy about technology, we look into many different technologies, not just autonomy apparently. And we spend a lot of time and also investment into developing our autonomous vehicles. But at the end of the day, we came to a point where we say, okay, customers are most important. So we sort of want to build a smart and practical product that can be enjoyed by customers comfortably. And I think that's why when Ain talk about scalability, when I ask Ain about scalability, it's not that we don't believe in it. We're working on it, but we sort of feel that there are so many challenges and there's so many things that we have to watch out as an operator, because apparently safety liabilities, especially when you deal with different markets at the same time. But I don't feel that it will be materialized. Probably not in the near term, though. Probably because our use case is different. So I understand where Ian came from when he talked about autonomy and self and driverless, basically. And I think for passenger cars, it's going to be much more complicated because the redundancy has to be very sophisticated. And I think radar is definitely in our opinion, radar is not sufficient. And I'm sorry, Maha, to say so, but we think that radar is definitely very important. But it really depends on the type of experiences you want to give to your customers. For example, we live in auto parking, and that's where we think that ultrasonic or cameras are still very much important as well. So I guess that's my feedback to many of the topics that you guys just mentioned earlier.
Wow, very interesting points. Thank you so much, Lynn. I would like to turn to another topic, air taxis. And I think this is something that a lot of folks have questions on and have interest in. Moshe, can you elaborate more on air taxis and where you see that going in the future?
Well, as I said, air taxis have been on the drawing tables for several years already, and air taxis are flying today. Several of the traditional aviation companies and new aviation companies have built the air taxis. The drone or the revolution of the UAV and the commercial world have started less than 10 years ago. Well, I'll tell you a little story how I got to all this business. Well, I served for more than 20 years as a helicopter pilot, a commander for the Israeli Air Force, logging thousands of flight hours in complex operation. Years after I retired, I have learned that the Israeli Air Force does not have a system that would support helicopters not to collide with each other, helicopters pilot. Back in 97, the Israeli Air Force had a very bad accident where two big helicopters collided and 73 soldiers were killed. Years later, they didn't have a solution. That's how I came into this area. And with my fellows, we have established Siconia. We have started developing collision avoidance system for helicopters. And we produced prototypes. The Air Force have tested them, and they were very happy. While working on this, we noticed that the real world or the real challenge now is integrating UAVs into the national airspace. So we have started working on this, and it was like 10 years ago when this revolution has begun. However, in the last 5 or so years, a lot has been invested in air taxis, and I'm referring to your question. So the vehicles are very close. In fact, they can fly in the very near future. They can safely take passengers. They will take off safely. They will fly safely. They will land safely. They would safely face challenges of weather, of obstacles, and it is a solved problem. They used several kind of sensors. They know how to fuse the sensors together. They know how to meter the systems, the engines. There is redundancy built in these vehicles. The only thing that is still remain to be solved is the integration of these vehicles into the existing air traffic management. This is quite a complex issue, the integration into the air traffic management. They are the airports that are very well organized everywhere, where the air traffic controller knows where every airplane is exactly, and he knows everybody what everybody does, and the pilots must obey very strict routes. And on the other hand, they are the open airspace where everybody can do what he wants and just look and be seen. It's the total responsibility of the pilot to see and not to collide with anybody else. Now, the UAVs or the unmanned or uncrewed, whatever you call them, then even the names must be changed, because an air taxi, he is crewed. I mean, it takes passengers on, so it is not unmanned platform. It is manned platform. However, it is not pilot on board, or the pilot is doing different activities on board the vehicles. So the integration is the issue. How to integrate an air taxi into the airport? Can an air taxi land in airport, take passengers, and take them to the city? And if you can integrate it into the airport, how would it fly out of the airport? How would it coordinate with just helicopters that are flying there, or with other UAVs, or with other air taxis? And this is where the world is busy today, in the US, in Europe, and everywhere else.
Moshe, thank you so much. Thank you to all of our panelists. That was a very energetic and spirited discussion. I really enjoyed it. And now, to continue the discussion, I'd like us to consider our second key question for today. Panelists, please see the link in the private chat on the right-hand side of your screen to answer the second key question. What do you think is the most challenging innovation that will disrupt the market for mobility in the next 10 years? Okay, we see some answers coming in. Sustainable energy, okay, very interesting. All right. And scaling of autonomous consumer vehicles. Okay, oh, there's some very interesting points here. I think we have all our panelists' answers in. Yes, thank you so much for sharing these answers. These are all very interesting. And so to kick things off, I would like us to start talking about sustainable energy. And I'd like to ask Lynn, would you please share some thoughts on sustainable energy for mobility?
Actually, it wasn't something that I put on the screen. It was different.
Okay.
Anyway, it's okay. So I think apparently everybody is working towards we joining hands in order to work towards decarbonization, a green world. I think it's definitely one of the topics that you hear everywhere. Well, I think at the end of the day, it takes all of us, right? It takes a lot of effort. It takes many companies to join forces, and it takes the customers to support us in order to make it happen and to really think about how to transition from a conventional, fuel and gas driven vehicles into an electrified vehicles industry. And I think in order to do so, we have to take one step at a time. And one of the things that we always think about how to be able to make sure that the adoption could be as fast as possible. It could be as attainable in terms of pricing, and it could be convenient and comfortable for customers. Because with our customers adopting, this whole trend, and then with our customers feeling comfortable and being able to afford an electric vehicle on a wide scale, then I think the sustainability will be, very far ahead in the future. So that's why I think some of the elements that we think are very important. And the first step is really to think about how to make those electric vehicles smarter, more practical, apparently, environmentally responsible, but also economically feasible. And I think that we have a high chance to make history with smart electrification, helping us, thinking about a longer step when it comes to sustainability. And this is something VinFast and Wind Energy Solution have been working on in the past few years to help make it happen. And I do think that it needs a lot more. It needs a lot more companies joining the electrification industry in order to make it happen. Yeah.
Ayn, why don't you chime in on what you think it would take from the grid perspective to achieve more sustainable energy for mobility?
Yeah, and it's a good question about sustainable energy, because when I think about all of us on this panel today, we're all solving pieces of these equations to bring these advanced technology vehicles to market. And I can see myself, I want to go talk to Maha afterwards about radars, and I probably want to chat with Lynn about vehicle architecture at some point, because like all of us are solving pieces of these equations. But even if like tomorrow we flip the switch and we all had EVs and we were all charging our vehicles, whether at home or try to out in general public, the electrical grid would crumble. It's just not ready, not even ready for it. And there's two different ways to solve this problem. We can either get more efficient with the technologies and how we generate electricity, or we can try to get the infrastructure to try to come up to speed, which we know is going to take a lot longer because now you're working with government regulators and you're having to build infrastructure. And so selfishly at Faction, one of the things that we started doing was working with smaller vehicles. And as you can see, the image behind me is more of a concept vehicle we did when we first started, but we prototyped a lot of our technology on power sports class vehicles that were three-wheelers that we then started working with OEMs who produce these vehicles as EVs. And what we end up with is a vehicle system that, if you compare us to something like, let's say, a Hummer EV that was announced recently, it's a 9,000-pound EV. You could essentially, for the same material, build 8 of the vehicles you see behind me for one of those kind of really oversized large EVs. I also have, this joke I tend to make that, trying to go one size fits all with larger EVs for every application doesn't make a lot of sense. Bringing any of us a pizza in a 6,000-pound vehicle with 300 miles of range is not sustainable. But at the same time, by right-sizing some of our vehicle applications, we're alleviating the pain on the electrical grid and how much energy we actually need to generate to move these vehicles around. When you start to look at fitting the vehicle to the application, with these smaller vehicles, it's about 50% of the energy on board the vehicle can be used to move the chassis. The other 50% of the energy is being used to move the payload. In most large EVs, even today, 90% of the energy in the batteries of the vehicle are being used just to move the vehicle. And so that it's not only wasteful, but it also leads to eventual, how do you recycle these things at the end of their useful life and e-waste and everything else. But I think, using blended fleets of vehicles, thinking about how we get smarter about how we build these vehicles will allow us to be more sustainable with the energy, but we have to solve it on all fronts. And I think there's technologies like whether it's solar, microgrid, how do we get storage closer to the charging points? These things have to happen or we're not going to be able to scale. So despite all the work of everybody, I think on this panel, unless we have additional companies focused on batteries, storage, generation, grid, we're going to hit a point where we just can't deploy as fast as we want to and scale as fast as we want to. We're going to get held back.
Yeah, I fully agree with Ayn and also with Lynn on this topic. We have to learn from the semiconductor shortage that everybody now is experiencing. We see like OEMs are reducing their production because of the semiconductor shortage. Others are becoming vertically integrated, building their own chips. So on the energy side, there are two factors. The internal factor, which is the energy storage, the battery itself. We've been hearing a lot about lithium, and that's something that you cannot just build new foundries to produce more lithium, right? So it has to be a new technology for storage. And here is where the academia and governments could probably bring themselves together to find a much smarter way to store energy. And then, of course, the external factor is the charging. So one thing, of course, of owning a Tesla 6 years ago is that I can charge it anyway for free, which is great. But I also have a huge solar panel at home where I produce 3 times of the energy I'm consuming or I'm using to charge my car. So eventually, these infrastructure, they're going to become smarter, allowing people with homes or with surfaces that can capture more solar energy to basically use that area to offset that needs in the grid, at least temporarily, to charge my neighbors' cars, for example, who do not have access to these places to install solar energy. So, there are ways that we can solve the problem temporarily. This is all temporarily. But eventually, over the long front, in my opinion, it has to be a new technology for storing the energy, electrical energy.
I liked Maha's comments just now about the new storage required, and we definitely see that in aviation as well. There are serious limitations in terms of the battery technology today, in terms of the density today, but it's a very exciting area for us. There are more than 200 startups working on electric and hydrogen powered aircraft. There are folks like Volocopter, Joby, Lilium, Zero Avia, and Universal Hydrogen. So it's a very, very exciting time in this space. There's a lot of capital flowing in, which is fantastic. And it has a potential to be truly disruptive for the industry. The aviation has made really big commitments around emissions reduction, reducing emissions by 50% by 2050 based off the 2008 numbers. And while we are looking at sustainable aviation fuels to drive a significant portion of that, hydrogen and batteries will be a really big component and a really important component of that. But again, with battery technology today, there's some serious density limitations. So where we're seeing in terms of the use cases is really around urban. We talked a little bit about eVTOLs, which are vertical takeoff and landing, that being a primary use case. And it's really one of the reasons is really driven by kind of the mission limitations that come from the density that's available today within batteries. And then the other piece is hydrogen. So when we kind of chart the mission and the aircraft size, there's kind of a trade-off between those two. We often see that maximum we're seeing about 9 seats is capable for having some kind of electric propulsion. And then you can get a little bit beyond that with a hybrid. But once you get past about 19 seats, we're really talking about, the entire plane being taken up by batteries, and it kind of defeats the purpose. And so we start to talk about hydrogen as being what's going to take us beyond that kind of general aviation, regional mission length. And so with hydrogen, the challenges are really around how do you distribute? Is it flow cells? Is it burning hydrogen? And of course, there's environmental implications with that as well. But most importantly, what's the distribution system in which you're going to be able to meet the needs and create that network and that footprint on the ground for actually making it viable for aviation from within a point-to-point system or hub system. So really exciting times from a investor's perspective in these two areas, and excited to see how aviation is going to change over the next 5 to 10 years because of these two technologies.
I'd just like to maybe add a question on top of that, because it's a category I'm excited about as well. As even though it's not directly related to what I do on the ground-based vehicles, we have some similar challenges where you can't put enough battery on aircraft to be able to solve all these needs. To your point about sustainable aviation fuel, there's even here in Northern California, they're starting to phase out fuels like 100 low lead, which are having a direct impact on general aviation fleet, where there's certain aircraft just won't be able to land at airports now because they won't be able to refuel. So as we move towards future tech for electric aircraft, to your point, we're not going to be able to fit enough battery on board to do everything. So it feels like there is a hybrid solution coming at some point. Is hydrogen, and you named off some of my favorites in the aviation space working on this problem, but is hydrogen looking like the lead here, or are there other technologies that are going to be emerging technologies that will give us these hybrid solutions? Because I think that this is also where the ground-based.
I've definitely seen electric hydrogen hybrid is interesting. I think jet fuel and electric and jet fuel hybrid. Well, theoretically, you can get the mission length longer. You have to essentially have two propulsion systems, and so there's a tax on creating the hybrid, and there's a complexity. One of the nice things about the electric propulsion, and it's the same thing with ground vehicles, is the simplification of the you don't have a combustion engine anymore. So it's a simplification of the propulsion system. But when you have a hybrid, you're adding all that complexity back. And so from a maintenance perspective, it drives up a lot of costs. I think one of the benefits with electric is the simplification from a maintenance perspective. So I don't know that hybrid, electric, and jet fuel is actually going to be adopted widely because of that complexity. So hydrogen is fascinating. There's a lot of road to plow in terms of, stability and safety, achieving from a safety perspective. So there's a lot of work to do, more in that proof is in the pudding and flight testing. And so, folks like Zero Avia, High Point, Universal Hydrogen, H3, they are all working to prove that out. And in different size aircraft, but we are seeing that they are trying to, for example, approach the regional jet size, which is more, 40 plus seats aircraft, which is, it starts to get more exciting because the economics, it all comes back to economics. So even though we love all these green technologies, it all comes back to aviation's very highly commoditized. You know how people choose their tickets. It's through schedule and cost, and it's been proved over billions of times through billions of purchases. And so we really have to make sure that even though we're introducing these new technologies, that we're actually meeting the value proposition for the end consumer, which is affordable ticket prices, and you get where you want to go quickly, right? You don't want to take 3-stage lengths to get where you want to go. And so I always kind of remind the entrepreneurs that I work with that is like, great, these are exciting technologies, but how are you getting, is it convenient and is it affordable? And if it's not those two things, then I think that's one of the challenges that we think about when we're looking at the urban mobility sector are you solving for the whole passenger journey? And if you're not, how it doesn't matter how cool your technology is. So I always kind of remind our entrepreneurs that we work with of that. So it's not just the cool technology, but it's actually, are you solving the right missions, and then are you actually delivering the right value to the end consumer at the end of the day?
It's a very good point, because we were victims of this in the self-driving category too, where people were they were basically building, $200,000 to $400,000 vehicle systems, and then it's like someday we'll cost reduce this, but unless you're building a product, you're never going to scale it. And I think I completely agree with the aviation side as well too. Your competition is that cheap ticket.
An interesting point when we talked about the energy storage earlier, we had a lot of discussions about the eVTOLs, and one of the big challenges is that during takeoff and landing you have a tremendous peak in the power demand, and when you go talking about hybrid, then there is always the easy say, during cruise you can use something like a fuel cell and so on, but the problem is this high power demand and the high discharge rates you need if you only put in small batteries, where you say, I just use them for takeoff and landing. Then number one, you still have tremendously high discharge rates. And the other point is you hardly have any reserves. And so one of the points, which in my opinion, I don't see a lot of discussions, is on how to balance that, because if you see the design missions of many eVTOL companies, then basically, in my opinion, the hover times which they state are very illusory when it comes to certification, because you assume that your landing pad is empty and you can land immediately. And one interesting comment, by the way, is I also never personally thought that the combination of electric with aviation fuel would make sense in this domain. But funnily, for example, you can now have converted APUs, which are using aviation fuel to produce at a very lightweight unit power in the low megawatt range. But still, I don't see yet a good mixed architecture for these eVTOLs when it comes to the peak power versus the low continuous power need. So if anybody has a comment there, I would be happy.
Well, another aspect that I talked about before is since the vehicles are ready, in fact, today, and drones and are flying already, delivering packages already, inspecting infrastructure and monitoring constructions. Air taxis will fly soon. However, it is all very rare. When we take up our heads, we don't see them in the sky. Now, the nature of this industry is that it cannot be pre-planned like a airplane can. An airliner knows exactly what it would do in a few days' time. It's not the case when a UAV is supporting construction. Because it depends on the work on the construction site. And if he needs to pre-plan it a few days ahead, it won't serve anybody. So, UAVs, drones, and air taxis very soon will serve first responders Now they cannot pre-plan where the fire will be, or the police cannot pre-plan where the robbers will attack somewhere, and they need these vehicles to support them. So the nature of this industry is that it is flexible. You cannot pre-plan everything ahead of time. A delivery drone do not know ahead of time where it will go to, because the whole idea is that to provide the goods an hour after they are ordered. So it can't be pre-planned industry. So the nature of the industry is flexible one. And that is why there will be mid-air conflicts if these vehicles are allowed to fly. Many of them will fly, will share the skies. Now, how these conflicts can be solved? Well, at first, people thought that they would be solved by sensors that would see what's happening around the air platform. Once the air platform knows what happens around him, he can make the decision. However, sensors cannot solve to the level of safety that is needed, because level of detection would not be high enough. Some of the vehicles are very small. The background is noisy, and the signal to noise ratio is very low. So detection rate is not enough. Anyhow, sensors cannot solve. Sensors are important, and sensor fusion is very important, but sensors will not be the solution for mid-air conflict. Well, the solution is already there. It is being used for many years already. It is all vehicles share the airspace will share their location via V2V direct radio network. This solution is working for aviation in TDK system for airliners for many years already. And the reason it is not in place yet for this new industry, for air taxis or for UAVs, is not technical one. It is more regulatory. It is more of a political issue, because the general aviation pilots, they don't want to install anything on their plane. They say, hey, why should I fly here for 100 years already? Why would I put another radio on my system? And now they don't want to put the radio. However, they cannot see a UAV that is flying in the sky. So either they will put a radio, or the UAV will not fly, or there will be mid-air collisions. And this solution these dilemmas must be resolved by the regulator, by the policy makers. And the only feasible solution that would allow this good industry to develop is forcing everybody to use to share their location via a V2V. And I believe that there is a justification to force or to make this regulation, because these the UAVs, the drone, the air taxis is a very good industry. It takes load off the roads. It reduces pollution. It takes it's good jobs, and it is a good industry that should be allowed to develop to its full capacity.
Great. Well, thank you, Moshe. I think this is a great observation. Although I always think forwards. I try to learn from all the technologies that are available. So in terms of sensors, the technology maybe is not available today, but that's exactly what MetaWave is working on, to be able to detect these small objects and have this very high signal to noise ratio up front while working with the sensor fusion. So Len, yes, I'm a big fan of radar for obvious reasons, but as a physicist, I work on 1550 nanometer optics, including LiDAR for military applications. So the technology is available. So we should not look back on what can be done, but look forward. V2V communication between drones, in my opinion, is impossible because of the battery consumption, because of which frequency band, the regulations, the standards, that's going to take time. But sense and avoid, and also a smart sensor fusion that can detect this power line during takeoff and landing, that can detect flock of birds and identify them, classify them. Now, here is the key, Moshe, is that are you training these objects offline? Is this an offline training for object classification or real-time fusion? I think I'm a big favor of real-time fusion. We're still very far away from this kind of technology, but for aerial, in my opinion, is going to be a must. You cannot just keep flying around and hoping you can capture all the data set that you can train your sensor fusion with. It has to be real-time fusion. But you know what? AI engine is just the beginning. I think we're going to get to a neural net, or maybe you're going to call it something quantum net, that can enable us to do that in a very economical way.
Sensors are very important. I agree. And the future, there is a future for sensors. However, it would take time to reach to the high level of safety that is needed for aerial transportation. However, the V2V does consume very little energy because it's very narrow bandwidth and it is short range transmission. And it is technology that is already there. It is proven, it is very safe. So if we should implement right away, or not right away, of course, but in the near future, the V2V, and in parallel, running and building and improving those sensors and giving the delegating more and more authority to sensor-based systems.
I completely agree with Moshe that the V2V would be the best solution. And unfortunately, I have to agree on his statement. This is mainly about politics, because I can give an example. In Germany, they wanted to only turn on the lights of wind power installations when an aircraft is in the vicinity to get rid of people complaining. And so they discussed about only for nighttime VFR making transponders mandatory, and there was a very big opposition to that. So in my opinion, whenever you come up with a technical solution, and I agree that V2V is it, the big question is, how do you decide globally or in a large aerial context on a common standard? And the second thing is, especially in free societies, how do you get to the agreement that everybody is willing to adopt it? Because unfortunately here, the challenge is really not the technological one.
I just want to actually come back to the initial topic when Andrew raised a question about sustainability of energy, because I think I feel that electric passenger cars are already playing the leading role in sustainability effort, just because adoption is earlier than any other form of mobility. And I think it's important to continue to allow affordable adoption of electric passenger cars, either through creative business model, including battery swap or battery leasing, but also with technologies advanced enough to address the basics like safety, cycle life, or range anxiety. But it doesn't mean that we have to stop looking into new innovations. I think new innovation will be mandatory to support sustainability of energy, whether it comes from battery chemistry or manufacturing technologies, or all those technologies around the supply chain. Whether it's primary mining or recycling, even technologies around manufacturing those precursor active materials at a higher yield rate, at a lower loss rate. And I think each of the players in the market also need to think about how to allocate the resources and the supply chain, especially now that many of us are playing in different geographies.
Thank you for that comment, Lynn. And thank you all panelists for sharing your many insights with us throughout this lively discussion on our two key questions. Now, I would like to give the audience a chance to respond. Audience members, please get your mobile phones ready to scan the QR code or have your browser window ready, as you will be able to vote on the answer to each discussion question that you thought was the most exciting or interesting. You can find the link in the private chat section on your screen. These should give you access to a digital polling tool. And first, you'll be asked a question about what part of the ecosystem you represent. So we see people from startups, people from academia, people from industry, investors, government and nonprofit. Okay, seeing answers coming in, investor and startup. Very good. We have roughly 1 minute remaining on the time, and it's pretty balanced between investor, startup, and industry, roughly. Yeah. And you can, as you see, the QR code is available. If you'd like to scan that, that will bring it directly to your smartphone where you can answer the questions. So we have about 45 seconds left. And oh, we see some folks from government and nonprofit. Very good. Please keep those answers coming in. We really expect a lively discussion on the audience perspective. So we really want to hear from you, the audience. Okay, it seems pretty much most from industry. About 15 seconds left, and a good amount from startups and investors. Very good. We are about to close, about 5 seconds. And okay, that's on the first question. So for question 1, we would like our audience to basically respond to which they thought was the most interesting answer for question 1. Okay, we can continue the voting. Should have the question on your screen. And here it is. What do you think is the most impactful innovation that can be realized in the next 5 years? We can see, lots of responses coming in. And it looks like delivery drones and air taxis is in the okay. Actually, we see self-driving and shared right-size EVs also taking some prominence there. No one has answered yet for automation safety, but we see some good responses for decarbonizing technologies and smart electrification. But in the lead is self-driving and also delivery drones and air taxis. Okay, we have about 5 seconds left now. And we've got some really great responses from our audience. Thank you so much, audience. And so the voting is closed for responses from the audience on which of the answers to question 1 they thought was their favorite. We'd say probably the top 2 can be self-driving and delivery drones and taxis. So to get us kick-started, Florian, would you please share your thoughts on why do you think the audience was so keen on delivery drones and taxis?
First of all, I assume that the audience, of course, of this meeting is quite technically affine. And so, of course, this is a completely new mode of transportation. So it's a disruption because especially with the vertical takeoff and landing, it's something that is different from everything which you had before. And so it can provide solutions to new transport demands. For me, it would have been very honestly very interesting how it differentiates between delivery drones and the air taxis, because I see the two domains much further apart than, for example, I had the feeling that Moshe would see them. And again, with the air taxis, the big question is, do they really have to be fully automated, or will they have a pilot on board in the beginning? But your question, why is it so popular here, is because I think it's just something completely disruptive.
Sarah, what are your thoughts?
Yeah, so I'd love to add here. I think one reason it was so popular is because if you think about where most consumers live, it is in an urban environment. And so by 2050, 60% of the world will be living in an urban environment. And so when we talk about drone delivery, most of the last mile use cases are either in the suburbs or in the urban environment. And then, of course, air taxis is all about how do we connect our metro areas. And so when we talk about the things that impact people's daily life, it's getting goods, and there's the rise of e-commerce, right? And then the other big thing is people spend a lot of time in traffic. So the idea that we could reduce the amount of time that's spent in traffic, make it easier to get to the places where we want to go on a daily basis. I think that kind of just invigorates people's imaginations in terms of really unlocking that third space of air as a public resource, right, within the urban environment, and kind of changing the way we live our everyday life. So I think that's probably why that answer was so popular.
I think the comment I'll add on is that if you look at the two that were balanced there, both air taxis and also self-driving, it's to Sarah's point here. These are things that affect urban, suburban use cases that we're all very passionate about, and I think that's why a lot of us are working on this. But I think we also have to think as technologists and people working on these problems. We have to also come back to a comment that was discussed earlier about all of us that are excited about technology. Can we actually take this technology and turn it into something that you can operate profitably and cost effectively so that we can actually deliver on these promises? So this is why I think similar to what we do with these light electric vehicles, drones have the same problem as well. We're competing against somebody who's willing to drive a 10-year-old car to go do a delivery to your house for extremely low wages through like gig worker kind of services, which we also know is not sustainable because they're maxing out, not getting enough drivers to be able to do these applications. But everything we try to deploy, whether it's light electrics, whether it's the drones, there's going to be a price point we need to hit, and there's also got to be something that we can not only apply the technology at the right price point, but then also do the services at the right price point. And I think it's going to be an exciting thing for the next few years, because I think you will see light vehicles, you're going to see drones, we're going to see the combination of them, how they might even work together to deliver on this stuff. So it's going to be fun. But I totally understand why people find this exciting, because it is very personal to all of us that if we solve these problems well, it's sustainability, it's accessibility, it's even making this technology more applicable to not only the tech centers of this world, but it affects everybody. And you can even get these technologies out to the rest of the world where maybe historically was not accessing these new advanced things too.
I want to be a little spoiler here, because I don't think that for congested downtown areas, urban aerial mobility will ever be a significant means of reducing congestion. As I said, there will be a lot of really cool applications for it, but it will not be a remedy to urban congestion.
I think it depends, Florian. If you are in New York or in downtown San Francisco, I think it will, definitely. Anyway, but I want to just bring up geographical needs. We all went through COVID. We all went through lockdown where you cannot even find drivers to drive these delivery goods to the people. In some areas, drones are essential to deliver medication, to deliver essential needs to remote areas. But my favorite application, and during COVID, was if I can fly a drone into the jungle or into the safaris and just look at nature and be outdoor without leaving my house. So I think travel is going to be a key for drones, and I would love to be one of the first one to fly that drone. I just watched Obama's recent Netflix series, and I every time I see those scenes, I just remember if I had a drone and I could fly it and discover all the species myself. So it's exciting.
Well, I've just learned recently that in Paris alone, 500,000 small packages are delivered every day. So imagine if half of them would be delivered by drone, it would impact the transportation. As of how many people can be flown or can be transported using air taxis, well, there is some work to be done, but creating a landing point or landing port for a vertical takeoff air taxi, it is much simpler than a subway station, because it doesn't require to dig the whole city, and it can be used, or it can use existing infrastructure. So building vertiports is rather easy, and many vertiports can be established on board existing roofs. You don't need to strengthen the whole building. It's not a heavy vehicle. And I made the calculation how many people can be driven in a single city. A lot, hundreds of thousands can be, if the system is in place, and it is not far away. It is achievable.
Wow. Thank you so much. I really like this discussion. All the points that were made were just incredible. And now it's time for our audience to vote for their favorite answer to question 2. Audience members, please scan the QR code on the screen or feel free to access the link in the private chat. These will give you access to the same digital polling tool to choose your favorite answer to question 2. We can see the QR code on the screen. You can use that to access the polling tool. Okay, sustainable energy. Very nice. Coming in first. A very notable topic. And scaling autonomous vehicles, taking the lead. Urban air mobility certainly that's a topic that lots of folks seem to want to discuss. But sustainable energy still back up there. Seeing full autonomy with scale getting some prominence among the audience members. We have about roughly 30 seconds left, so audience members, please get your answers in to what you thought was your favorite response to question number 2. Right now, we have full autonomy with scale in the lead, but followed fairly closely by urban air mobility and sustainable energy. Have about 10 seconds left. All right, just a few more seconds and our poll is now closed. Audience members, thank you so much for entering your responses. And I think now we can get a chance to discuss these. So number 1 would be urban air mobility. We've already done a lot of discussion, but I want to touch on our impressions of what we think the audience is seeing with urban air mobility. And I'd like to call on Florian. Florian, would you please share some of your thoughts on kind of what you think the audience is seeing in terms of urban air mobility? What are their thoughts?
So for me, this question is very close to what we had in the previous polls. There it was urban air mobility and drones, and now, or the air taxis, and now it's just reduced to urban air mobility. So once again, it's a complete new mode of transportation. And I see the big chances it has, especially in regions which are hardly accessible. So if you have areas with a lot of islands, areas which are very mountainous, so everywhere where basically it would be very expensive and complex to build ground infrastructure, or where you can have a very high gain of time, even over a short distance. Because I would see that eventually we come up with systems that will have a range of 200, 300 kilometers. And so basically there you will find a lot of connections where you do not have the good ground-based infrastructure. And there, of course, this will offer a lot of new alternatives, not inside the city from the supermarket to the house, but from one village to the other city behind the mountain. I think it's a great opportunity.
Yeah, I think I'm the one who put urban air mobility. So these are kind of distances that spans between half an hour to an hour, no more than probably 45 minutes, very short distance. I recently was in New York, and I always take a last flight. So I landed around midnight. I took Uber. A typical path that takes half an hour to my hotel, it took 2 hours because every single tunnel that Uber tried to go to was closed. Or a bridge. So at the end, it was just rerouted. If I just had an airport, one of those UAMs that can just fly from Newark Airport to whatever landing pad, and Moshe mentioned it's much easier to put a landing pad at a subway station. It would have taken me maybe 10 minutes, right? So productivity is key here. And we never touch on productivity. Productivity with driverless cars. Why we peg Uber and we decide not to drive and worry about parking? Because we want to be on our phone. We want to be on our laptops when we are driven from point A to point B. Same thing is going to be with urban air mobility. It's going to take time. It's not because the technology is not there. Yes, we've touched on the storage issues but I think when you are 20, 40 minutes even it's completely electrical storage should be enough. But it's the regulations. It's basically the FAA and all the regulation, the standards. It's going to take time. That's why I put it for the 10 years and not the 5 years.
Thanks, Maha. And I think, I do see there's entry into service is going to happen earlier than 10 years for sure. But I agree, it's going to scale, and it's going to scale in different jurisdictions at different times. There's areas of the world like Singapore, which are very leaning in. Dubai, for example, leaning in. The United States not really leaning in, kind of waiting to see the proof in the data, which will probably take place in other jurisdictions. You mentioned the island use case. That's a great example of where we might be able to prove out the data faster and be able to bring it back to jurisdictions that are more conservative. But another thing that's going to pace the scaling is really around infrastructure. So charging infrastructure, how quickly can we deploy that? Are our grids up to snuff to be able to fast charge an eVTOL? So, anecdotally, when I've been working with some of the electric aircraft makers, it is like bringing a supermarket on and off the grid when you go to charge an electric aircraft. That's huge, and a lot of grids are not at a municipal level are not ready for that. So is our energy infrastructure ready to support it? And then also, do we have kind of the vertiport footprint to be able to meet kind of demand, high route demand, right? It probably won't start as a free for all, go anywhere, but thinking about what are the high areas of high demand, routes of high demand within the urban environment. And then the last couple of things would be connectivity. Do we have the right kind of technology in place, whether that is a Ku-Ka band, satellite connectivity, et cetera, that you can support safe, and also in some cases Wi-Fi as well. Getting the right connectivity solutions so that within the urban environment, like you can handle the different kind of micro situations that will come up. And then lastly, thinking about kind of the UTM and how we work through unmanned traffic management. Honestly, I think we'll see manned eVTOL coming into the environment and scaling before we actually see unmanned scaling in any kind of significant way. So I'm excited about it. I'm a futurist first and an investor second, but we need to be pragmatic in terms of working across the industry to get the right infrastructure in place to make it happen.
So one comment I'll add, I think there's more reading into the audience's voting on the topic, because this was the question was, what is the most challenging one that we could do over the next 10 years? And I agree that the urban air mobility will be very challenging. That's why I think that's why a number of us are working on the ground-based problem now. But the reason I think the urban air mobility is near and dear to us is because ground-based is terrible right now. Like it's sitting in the traffic, it's the gridlock. And I think this is part of the mission we went on at Faction, to kind of right-size these vehicles, to try to get more vehicles off the road and try to use smaller things that more fit the mission. But with air mobility, they're going to face the same challenges we have even in ground-based with building a real business. Maha's story gave me a flashback about 10 years, 15 years ago. I was on a trip landing at JFK where I had to get down to downtown New York. And there was a service at that time off of Terminal 9, I think it was, by American Airlines, where you could hop on a helicopter and they would fly you into downtown and land you at Rockefeller Center. But that service was $100 for the trip, where a taxi was $50. Now, for somebody on an expense account for a business, that might not seem like a big delta, but for the average population, people weren't going for it. So they would fly those helicopters on occasion to give people the quick hop to downtown, but it didn't sustain itself. They eventually went out of business and they discontinued the service. But I'm sure, as Maha was describing, if she was faced with a 2-hour drive, she would have gladly paid $100 to hop on a helicopter to get into downtown New York.
I would have paid $500.
Exactly. Your time is your most valuable thing. So I think it comes back to the point that whatever we deploy, it has to be competitive. And there may even be hybrids here where you throw your luggage into a Faction vehicle and it takes it for you while you hop on an eVTOL and then you hop into your meeting and your luggage is waiting at the hotel when you arrive later in the day. But these combination of solutions is eventually going to be, I think, the future for how we deal with this. But I think that the passion behind air mobility is really because we all hate being on the roads today, and we need to solve a way to get less congestion, less traffic, everything else, in addition to building some of these future technologies for how we get around to.
Well, I'm not surprised by the results of the vote because it's the same as the industry votes. And this is why the meter conflict issue is a bottleneck of the industry, because not enough attention is attracted and not enough resources are invested. And it's not only money, it's also from the regulations point of view, not enough invested in this area. And this is why it's a bottleneck. This is why it stops the industry. And the results of the vote reflect the same phenomena.
Wow, thank you so much to all our panelists for sharing your thoughts on the audience reaction. And so now we will take the last half hour or so for audience Q&A. If you are joining us in the audience, please feel free to post your questions in the chat section. And as your questions come up, we will dive right in and share some answers. One question I'd like to start with is, why do we think it's taking so long for drones to capture a significant market share of last mile delivery? And I'll direct that to Florian. Florian, what are your thoughts on that?
So when you're really talking about the last mile delivery, then it means that the drone has to land at the location of the final customer. And basically, when you want to guarantee safe operations, it's always, of course, easier if you have dedicated takeoff and landing sites where you can ensure obstacle clearance, where for the sake of availability. So remember, you don't always have good visibility. You can have other visual obstructions. Of course, landing in a completely unprepared environment is the hardest thing. So when you talk about, for example, drone services between hubs or between, let's say, delivery centers, this is something that can be managed quite easily, or to a packing station where basically people would still go to pick up their package. But if you really want to fly to a home, you have to land in a very unknown and complex environment. And to prove that this is really safe with all the people on the ground interacting is, in my opinion, the challenge that makes this the hardest task in the end.
Will legacy automotive OEMs adapt fast enough to stay competitive with new technology EV automotives that are moving ahead quite quickly with both technology and market share? I'd like to direct this question to Lynn. What are your thoughts, Lynn, on legacy OEMs and their place in the market?
Well, I don't want to be biased, right? But my observation is really that new EV startups will definitely have a high chance in this electrification race. I think one of the technical challenges with legacy or those traditional OEMs is really the transitioning and the conversion from manufacturing an internal combustion engine vehicle to an electrified vehicle. And if you start from scratch, normally it's faster. If you have to convert from what's already been around for some dozens of years, then it will definitely take more time. And I think this, also I see a lot of startup EVs coming out of Asia, and I think that we sort of behind when it comes to automotive industry. So I think the way we do it is really to be able to catch up with the race in automotive industry in general as well. So I don't mean to say that we work harder, but we do work harder. And I think this is something that quite well known in many different parts of Asia, especially areas like China or Vietnam. And I think we definitely have a very strong determination, because this is a big game. It requires a lot of investment, it requires a lot of trade-offs. So I think, with all that, I do feel that there's a strong, positioning for those new startups, especially those coming out of China, or many, other Asian, especially Vietnam, because I think thinking about bringing the vehicles outside of Vietnam, outside of Asia, I think we're probably in a quite unique position.
So I'll add a comment, but I'm slightly biased, like Lynn as well, on this one. There's two key points here in terms of when you think of the evolution of these, and I'll tell a little bit of story, but I won't name the tier one by name. I spent a number of the past several years working with companies that were either T1 suppliers to automotive, and as well as having conversations with the legacy OEMs. And I had this one conversation a couple of years back with one of the top suppliers of components to the automotive industry, and it was around the topic of how do we build digital architecture on board next generation vehicles for networking components and safety systems. And we were talking about putting Ethernet on board vehicles to run high-speed data from the cameras and radar and anything else we might put on the vehicle. And one of the lead engineers at this major OEM that supplies very large companies in around the world says, no, we're never going to put Ethernet on the vehicles. It'll add $30 to the cost of the wiring harness. And I sat there and said, yes, it would add $30 to the cost of the wiring harness, but you're going to be unblocking billions of dollars of potential revenue with these advanced vehicles and enabling new capabilities. But this was the mindset of a very mature industry that was thinking in how they optimized for their current world. And so that kind of thinking prevents companies like that from moving quickly to adopt the new technologies. And to Lynn's point about the pace at which the evolution's happening in Asia right now, the future vehicles are architected from a systems architecture standpoint, a lot more like a digital consumer product, like a smartphone, than they are a legacy vehicle. And so the companies that are better positioned to move quickly into that type of vehicle thinking are the ones that are going to win. And what's going to happen is the legacy companies that don't move quick enough, they're going to get killed. And the other, I think, underlying technology that is very important for people to keep an eye on is the battery supply chain, and the innovation around the battery supply chain is all happening over in Asia right now. And while we talk a lot about OPEC for oil, the OPEC of the future is going to be the countries that control the battery supply chain. And those countries, it's China, it's Korea, it's Japan, it's all in that orbit right now. And that's something we all have to keep an eye on. And I think Lynn also touched on this accessibility, because we don't want it eventually for the globe to be successful with an EV transition. These technologies have to be available to everybody, but it's being led by companies that are not the legacy companies in this industry. They're pulling from that supply chain now, but they don't own the IP, they don't own the tech. And so what looks like a legacy company today that's a winner may not be the winner 10 years from now.
I just want to add quickly that digitalization and connectivity is definitely something important for new EVs, and that's why I sort of wanted to challenge earlier in the call when you talk about Tesla being the only one, because we definitely have a big strategy around digitalization, and I think a part of it requires some bold moves, including adopting quickly new technologies. And even the mandatory technologies like cybersecurity, because I think this is definitely something we have to watch out as we go more digital in the car.
And I apologize, Lynn. I used Tesla as an example from the US market, but I would love to take a ride in a VinFast vehicle at some point too.
I just wanted to touch on that kind of OEM versus startup dynamic. And when you think about it from a capital perspective, within an OEM, there's so much competition for how R&D capital is deployed. And so you've got your legacy, models that you need to kind of incrementally innovate on, right? And so you're talking about introducing something that might be completely disruptive to what the company is doing today. And so that internal competition over capital is what kind of creates that dynamic where maybe those big bets aren't made. And so, from my experience of working in Boeing and Boeing Horizon X, we had to have that arm's length organization that was able to go out and make some big bets that wasn't part of the core business. And the other dynamic that is really important when we talk about startups versus OEMs is that there's $17 trillion assets under management in the United States alone around ESG investing. that is a huge amount of capital that when you look at the balance sheets of an OEM is like their R&D dollars is tiny in comparison. And so when you talk about that 17 trillion and opening that up for startups and them being able to innovate, what I think will happen over time is we'll see kind of a more aggressive acquisition strategies happen within the OEM space, whether that's automotive or aviation. And that'll be their way to catch up from a technology perspective, because they simply cannot make all the bets to know what the winner will be. And so I think we'll see a lot of the innovation coming out of the startup space, and over time that'll get incorporated into the larger companies via an acquisition or merger.
So I've seen a question in the chat that was very interesting to me, where a founder of a company asked basically if we anticipate that the certification requirements for air taxis will be as slow and as strict as for classical aviation. And what I can say for Europe, the certification requirements there have been published in the special condition VTOL, and especially if you want to use the air taxis in urban environments and for commercial purposes, they are extremely strict. So my feeling is that basically the different certification domains around the world, so United States, Europe, and other regions like China, there will be a competition, because I think the requirements in Europe are overly strict. And my feeling is that there will be an economic advantage in the regions where basically the agility and the pragmatism in the certification is getting higher. So I hope that in Europe we will not have a too high disadvantage due to overly high certification requirements.
Great. We have a question from David. David asks, what do you consider to be solutions for dealing with tampering, like theft or deliberate damage of autonomous delivery systems? And I'd like to direct this question to Ayn.
Yeah, it's a good question. One advantage we have with the autonomous systems is that they have a lot of cameras and sensors on them. The vehicles we're deploying have a complete 360 coverage on the cameras, and it allows us to have a complete record of anything the vehicle's doing. So, technically, if somebody were to tamper with a vehicle or steal something from the vehicle, we will have complete footage of everything that had happened. So that is a little bit of a deterrent. The other advantage is that these vehicles have their own mechanisms for unlocking and locking the door systems. So someone will have to physically really work at this to get into a vehicle, and you're going to get it all on camera. It's not to say it will happen. It was one of these things we even talked about with the long haul trucking, where if somebody were to intercept a truck on a highway at some point, and block the road, they would have probably a good amount of time to work on that vehicle before authorities would be able to arrive, just because you're doing these long haul use cases. And we've already seen this happening in places like LA, where there's a lot of footage of the trains were getting looted down in train yards while they were staging for things over the pandemic. It's going to happen, but I'd say that the advantage we'll have, at least in the self-driving systems, is that we've got a lot of sensors and cameras on board, so there will be a good record. And so ideally, we'll be able to mitigate that through working with authorities.
Very good. Our next question is from Rakesh. Rakesh asks, mid-air charging of UAVs may be a good service. Are there any companies out there providing this kind of service? And I'd like to address this question to Moshe. Moshe, in your experience, have you found any companies that are innovating in the area of UAV mid-air charging?
Well, mid-air charging I haven't heard of. However, while hovering, or there are some, as well as I remember, there are some solutions to recharge. But I believe the technologies will develop to recharge while in air. I believe so.
Thank you, Moshe. Our next question is from Tina. Tina asks, what do you think about the race between battery electric vehicles versus hydrogen electric vehicles in the next 5 years? And I'd like to direct this question to Lynn.
Well, I think that when it comes to EV, we think about passenger cars versus commercial cars, commercial vehicles and passenger vehicles. I think battery will continue to play a very important role, at least in the next 10 years. And I'm referring to traditional lithium-ion batteries. Having said that, there are continuing effort and innovation in new battery technology as well. I think when it comes to commercial vehicles, hydrogen will stand a chance definitely, and I think the adoption in hydrogen would definitely be making more sense when it comes to commercial, rather than passenger vehicles within the next 5 years, due to a couple of factors. If you think about the hydrogen system to support the vehicle and the supply chain, then I think you probably understand that the manufacturing cost is only around 20-25% of the total cost. And I think the remaining goes to storage, distribution. And I think, storage and distribution are very still nascent at this point everywhere else in the world. And I'm not an engineer, but I understand that technically it will make more sense for hydrogen to go into commercial rather than a passenger as well. And there's still a lot to work on when you want to think about how to adopt a fuel cell system on the commercial vehicle still.
Great, thank you, Len. We have another question from Rakesh. Rakesh asks, how large is the compute burden for mid-air collision avoidance? And I'd like to direct this question to Moshe.
Well, it depends on the solution that is selected by the vendor. I know that there are a solution that is being developed by somebody else that is a very large burden. However, we selected a different approach where we try to implement, I would say, the human pilot's view into the computer. It is quite sophisticated solution, but it is very simple from the mathematics or the computation process. So it depends on the solution. Our solution is not a serious, not significant burden on the computation system.
So I was just going to comment really quickly on hydrogen within the aviation landscape. So electric versus hydrogen, I think that was a question that was asked earlier. When it comes to if it's a race, electric is going to get there first. Simply because where we are when we look at the kind of the hydrogen startups, they are further behind from a certification perspective. Entry into service is more in the late 2020s as opposed to kind of mid 2020s, which we're seeing for most electric aircraft. There are some entry into service targets around 2024 for electric aircraft and 2025. And those certification plans are pretty specific, which gives a level of confidence, even though we know that from a regulatory perspective, some of that can get pushed out, right? Because there's always unknowns, right, when you're going through a certification process. So hydrogen, the prototypes that we're seeing now, we've got Zero Avia and Universal Hydrogen. The entry into service dates are more in the late 2020s. That's from the vehicle perspective. And then you have to look at it from the infrastructure perspective. I think there's definitely more momentum around how do we solve the charging infrastructure question. I also think that when we talk about infrastructure, you have to think about it from an airport perspective and what capital is going to come to the table in order to support the infrastructure. We're just now getting the capital and also government funding to really support SAF distribution, sustainable aviation fuel distribution. That's happening first. There's more SAF at airports, right? And you can actually go on ICAO website and see where there is SAF being distributed today. Next, I think will be kind of the build out of electric charging, and then finally we'll see kind of hydrogen, the hydrogen distribution problem get solved. So that's really what is the pacing factor. I think is really the build out of infrastructure, and then also looking at the certification path in terms of where are the companies today in their certification processes. So SAF, then electric, then hydrogen is how we'll kind of see it play out. And then also too, when we think about the certification processes, a lot of the electric is Part 23, which is has a lower certification and safety burden than Part 121, which is commercial aviation. And so when we think about hydrogen, that target, the holy grail for hydrogen, is really commercial aviation. So that will inherently be a larger certification process and a longer certification process. So that's the timeline, at least from Sarah's perspective.
Great. Thank you so much, Sarah. We have a question from Albert. Albert asks a question directed to Lynn. VinFast is bringing four-wheel EVs to the United States. How about electrifying two-wheel transports in Vietnam, where there may be more bikes than cars? What are your thoughts on that, Lynn?
Thank you, Albert, for your interest in learning more about VinFast. I'm happy to say that we have been produced more than 10 e-scooter models in Vietnam so far since 2019. Our factory today allows us to produce around 500,000 e-scooters a year. And then we do have cell and pack facilities in-house as well. So actually e-scooter is quite advanced at VinFast compared to electric cars. But I think the strategy and the vision has always been around electric vehicles since day one, even though we launched the first 4 internal combustion engine vehicles within the first 2 years from inception. But it was a sort of, a bridging strategy in order to make sure that people understand that we know how to build the products, we know how to build good quality products. And with those 4 internal combustion engine vehicles that we only sold in Vietnam in the past 3 years, we also the best selling in each segment. And e-scooter is definitely always the best selling in the local market as well.
So at the end, of course, when you have an EV car like the one I'm driving at Tesla, when I run the autopilot, whatever you want to call it, I see that the range is reduced by 30%. It's mainly because it's very intense on the compute power. And that's what I call the brute force way of implementing sensor fusion. Whereas if you try to balance that complexity between the edge and the centralized compute, you can actually get much better performance at a much lower power consumption and cost. How do you do that? If you have a sensor like a radar that's able to detect a motorcycle at 300 meters, that it can alert the LiDARs and cameras exactly about these regions of interest. So instead of the sensor fusion wasting time and resources of scanning the whole field of view as they do all the time for safety, they can actually alternate between these regions of interest and the full field of view. And by doing that, early detection at these much longer ranges will further improve the performance, reduce the need for this high compute power that everybody is focused on today, and only with time. And I think today, of course, if you take a look at the sensors that are available from LiDAR, cameras, or radar, you cannot even do an unprotected left turn correctly if you have an incoming motorcycle very fast on your right. The driver has to always intervene. So this is where MetaWave technology is quite superior. And this is not only on the ground, but also on the air, being able to avoid these collisions in the air by detecting fast-moving objects, even if they are small at 7-kilometer range.
Maha, thank you so much for that response. And thank you to all of our panelists for answering the questions from the audience. This has been a remarkable session, and I think we can all agree that we learned some extraordinary insights and are much more excited about the future of mobility. I'd like to give a huge thank you to all of our panelists in today's session. It was a pleasure to have you join us, and thank you for sharing very powerful insights into the exciting world, the future of mobility. And today's session is now coming to a close, but this is a very important discussion that should continue. So please scan these QR codes to join and contribute to this engagement on digital transformation even after this event concludes. If you would like to share about DX Week, please feel free to share, use the tag #DXWeek2022 on LinkedIn. This now concludes TDK Ventures Digital Transformation Week. Thank you again to all of our panelists and to our audience. We will have Energy Week coming up in the fall, and I would like to wish you all an amazing 2022 and looking forward to seeing you again. Thank you.